Hello, this is Adventurous Man. What you see here, the three other things I've been working on, which I haven't caught you up on with yet. My gas, this calculates how much gas I'm catching. I've got this, which I've been working on. It's taking me a bit actually. A container sealed, so then I've got the gas output through to gas counter, I guess you'd call it, and also made a few of these basically for test purposes. The one I've got in the container itself is simulating the first one I've shown you, including with the parts with the electrodes down to energize the washers. This one, difference with this one is that I have insulated everything that will be going into the solution except for the washers. Okay, now the purpose of making these two is that I want to find out what the possible leakage current is and how much of an effect it has. Be doing that in two ways. Be checking the amperage. It won't be accurate, but it'll be close enough, I'm hoping. And I will, let's see, also by testing the gas output and timing it. Two ways. Okay. So what I've done is I've hooked this up to 3.3 volt source, which can handle 10 amps, so it can definitely handle that. In fact, I've had this running before, and it definitely doesn't come anywhere close to running over 10 amps. So I'll put it on now. Oh, there it goes. Put it on now, and there goes the switch. You hear that hum? It's going. Don't know if you can see that or not. See if we can get closer. See the bubbles coming off? Okay, so the sucker's going. Not too bad. I'm having a personal look. Bubbles are coming off the nuts there, and they appear to be coming off the electrodes there as well, though the main output seems to be between the washers. Pretty well much what you'd expect, considering that's the part that's closest together. Now let's see if I can get you. Okay, as you might be able to see, let's see if I can get you closer. There we go. It's running at just over 2 amps. That's probably very hard to see, very furry. You see that? Where that there is a 5. You see the graduations is the major graduations in between is an amp. And I thought I had the voltage going. Oh, I've got it hooked up backwards. Hang on. Doing this left-handed because I'm right-handed. Makes perfectly good sense. Hang on, change hands because things are a bit dicey at the moment. Okay, that's the negative. Hook up the positive as well. There we go. And it's running at just over 3 volts. There we go. Let's see. Okay, the amperage appears to be getting close, probably about 2.25. Okay, now also don't know if you can see that. See? Yep, you can. It's bubbling. Okay, now what I've done is I've kept the cap on, and I've got the cap open so that the gases can release. This means that I can start, it's easy for me to put the bottle in and out. I've seen several other ways of doing it since I've done this. This is what I've done so far. Okay, gotta find my watch. Here we go. Unfortunately, it broke off. The strap broke on me about a week ago. Been a hassle. But anyway, there we go. We got the stopwatch, and there's it going. Stopping and clearing. Okay. So obviously, I need to be able to start the watch, and we can start the process of recording the how much gas it's producing. Okay, so I'll do that now. Okay, there we go. Now, I did this before. It took about 4 minutes to do about 50 millilitres. That's quite a long time, which means I've got time to talk. Okay, so now I think at the moment it's going a lot faster. Unfortunately, I can't take the temperature. Things would be a lot more interesting if I could do that, and I'd keep them on a more regular basis. I'll have to remember to write down the results when I get it. Now, this is just to prove to me that there is in fact leakage current, and how much of a difference that it makes. Okay, as you can see, there's a wee lip of gas there starting to form already, so this bottle seems to be working quite fine, thankfully. See a little difference. There we go. I've got graduations. Oh, in fact, you can probably just see them there. Graduations there. I had to do that by tipping it the container upside down, and filling it with different amounts of water, and putting in the approximate locations of how much that was for a pretty rough not gas analyzer, but a gas counter, I guess you could call it. It's working quite fine. Used a fine tube. Now at the bottom there, that shadowy bit right down there, I didn't have to, but I thought it would be a good idea to actually weigh it down to keep it down there and to help keep it in place. So what I used was a brass T. I stuck the tube through it, and it seems to be doing the job quite nicely, thankfully. Now, looks as though this is going a lot faster than expected. So far, it's only been almost 2 minutes, and we're almost halfway there to 0.5, to 50 millilitres. Pretty sweet. Okay, so I've been working on this, which is the gas counter. Been working on this and these. I've made a few others. At the ends there, remember in my last video I mentioned how the washers are actually curved slightly. So what I've done is I've made a few others. I've got this one here. Washers are put together in such a way to provide a shape such as that. I've got, so the washers are going the other way, and I also have, let's see, I scored the inside with some sandpaper. Can't remember if it was 60 or 80 grit, but I did that to try that out too, because apparently that is supposed to increase the surface area. And then I've done this one, which is the bigger washers, which is what I'll actually be using. The surface area I worked out is almost twice, so it'll be interesting to see if the production is twice as much. Okay, now notice after doing this one, which is a real hassle getting the inside parts insulated with the silicone sealant, I used some liquid, basically a type of paint, and made it a lot easier. I think I still made a hash of it a couple of times, but I don't think we need to worry about it at this stage. It's just to give me an indication of how well we're doing. Now, surprise, surprise, we're almost at 100 mils. In fact, we'll say it is, and we'll say 100 milliliters at 4 minutes and 13 seconds. Now this isn't by any chance inaccurate. I'm not exactly being very accurate here, but just noticed time. I better take off. We'll catch you later. This is Adventurous Man.